Okay, so we're going to be taking apart this DeWalt drill. This is a DeWalt cordless heavy duty drill and hammer drill. It's a DC 927 type 1, so it was an earlier model. I think this is probably from around like 2008, 2009. It's one of the first lithium ion drills that, as far as I'm aware, that DeWalt came out with. Used the lithium ion battery like a cell phone instead of the older NiCad battery technology. This drill was used for a while, and then it started smoking the one day when it was used, and it was taken out of commission. So we'll take it apart and see what is on the inside. I've already taken the screws out of it, so it'll come apart. It is a combination of plastic, it's kind of rubbery over molding, and then some metal up here around the output. So we take the front off there. You can see this part is metal. I'm not sure if that's aluminum or some other kind of material. You can see the output shaft for the chuck is there. That's where the power will go out to the chuck. Take apart the clamshell design, okay, because it's two halves that come apart. Call it clamshell. You can see here there is looks like something got pretty hot there. Let's see, that would be right around this part of the trigger switch. So that may have been where this actually failed. I had assumed that this had a motor failure of some time because the smoke was coming out of these vents where the motor is, but maybe it was actually drawing it up and through the motor there. It looks like the battery would come in from the bottom down here. The battery would actually attach directly to this trigger switch. And you can see where there's copper here. This would probably be a heat sink to help dissipate heat from in this switch, because the variable speed on this probably uses an electronic drive. So there would be some MOSFETs or something in here that would do that speed control, and they generate heat, which is why you see this is all copper, and that copper would conduct the heat away from those MOSFETs and help dissipate it. Looks like there's some kind of material here between the copper and the switch too that probably helps conduct the heat. So this drill may actually work if it had a new trigger put in it. You can see on the inside of the clamshell here, there's lots of dust from the carbon brushes in the motor. Or at least that's why it's black. I'm sure this was used in a wood environment, so there would be lots of other dust that entered this as well. So looking to see if there's any markings on the inside that would tell us what type of plastic this is. TPE. I'd have to look and see, look that up and see what that would be. If we take out the motor and gearbox mechanism here, unplug these wires from the trigger, maybe. Oof. Certainly on well. You can see the motor is kind of a can design. It's completely self-contained. I believe it will pull out. Yep, there we go. Some of the newer drills actually use the clamshell, the plastic case here to hold the motor and the bearings and everything in place and keep everything in line. This one uses a different design. This may be an off-the-shelf part that DeWalt bought and put in the drills, opposed to something that was actually manufactured by DeWalt. You can see these are the brushes for the motor here, because this is a universal type motor, would run on AC or DC. These brushes are pretty worn. That groove there, because there's a spring that's supposed to go in here. The spring came out, but there's a spring that pushes down on this and holds it against the commutator in the motor in here. And once this brush reaches the end of this cutout, it can't push on the brush anymore, and they're almost there. So this drill had been used enough that it is ready for new brushes, which probably wasn't helping its case either. Power would come out here through this pinion gear and then go into the transmission, because this is actually a 3-speed drill. It has 3 different speed settings. See on top it has gear 1, 2, and 3. So in the gear case here, take this plate off. This is a planetary gear set. So the pinion gear on the motor would be the sun gear, because that would go in here to the center. And then as the sun gear on the motor turns, it's going to cause these called planetary gears here to go around. Okay, and they will orbit around the sun gear. Convinced to turn, maybe not. And then there's a ring gear around the outside here that also holds them. So what happens is, by moving this selector up here on top from different gears, depending on where it connects, there's a couple different sets of these that go down through. Depending on where it connects determines what speed output you get, depending on how many of these gear sets you use. If we pull this out, there's one ring. That's the planetary carrier. You can see what happens as the planets orbit around. Then they turn another sun gear here that goes down into the next stage. And I don't know if I can pull this next stage out or not. There we go. Take the next stage out. Okay, and then there's even a third stage that goes down inside. So then this planetary drives another pinion gear, which drives a third set of gears down inside there. You can see for that last stage, because this would be the highest torque, as it gets slower and slower, torque goes up. There's actually, instead of the 4 planetary gears here, 1, 2, 3, 4, there's 1, 2, 3, 4, 5, 6 to handle the amount of torque that would then be going into the drive here that engages the chuck. So you can see they've used a variety of different materials here based on what they're trying to do. Here in front, where there's going to be the highest amount of torque after the power goes through the gearbox, and there's also the most amount of leverage as the user is holding this drill and drilling. This part is made out of made out of metal, and holding that main shaft. So the bearings sound a little rough in there. Take that front case off and see what type of bearing is in there. But that part is metal. The gears themselves are metal. They're probably a powdered metal where it's compacted and then baked in an oven. You can see the piece that is holding the gear case itself together, though, is plastic. I suspect probably a nylon type of material, given the look of it, which is pretty stiff. But that's going to be selected for weight and also for cost. You could build this all out of metal, and it would withstand heat and stress a little better, but it'd be more expensive, and it's going to make the drill heavier. You don't necessarily want to have a drill that's super heavy to hold if you're going to be running this for hours. And the gear case made out of metal, and that probably is the heaviest item in the drill, next to the chuck and the front part of the drive here. But then, of course, the motor itself is secured within this plastic clamshell. And again, this would be selected for cost and for weight. Again, if this was all made out of metal, this would be far heavier than than these two pieces here. All right, so I did a little bit of checking on the markings on the inside of this plastic, and the PC plus PBT is polycarbonate plus polybutyl phthalate, if I'm saying that correctly. It's an alloy of two different plastics put together for basically toughness, a combination of factors, scratch resistance, resistance to UV light, resistance to abrasion, flame retardants, as well as static dissipation, which obviously would all be things you'd be concerned about when you're talking about a tool housing. And then this TPE underneath, that identifies the overmolding that goes on the outside here, that is on there, excuse me, to provide grip around the outside where the user is going to be holding on to the drill. So that is the disassembly of the DeWalt cordless hammer drill.